Use the graph grid below for question 57 through 60. And you can see the kind of stuff that we're going to be doing includes plotting points, finding the distance between 2 points, and we're doing that with the Pythagorean theorem. We are also finding slope, and we are also writing an equation of a line that's going through this point. So a whole bunch of stuff in the coordinate plane, this thing that's right here. So I'm going to steal it for a second. Like so, copy. And let's go down here and talk about stuff that has to do with the coordinate plane. In geometry, a plane is a two-dimensional surface that goes on forever. Coordinate plane, we put the x-axis and the y-axis on top of it just so that we can easily locate points in that plane with an ordered pair. It's called an ordered pair because you got two of them and it comes in a specific order, and that order is always alphabetical, x first and then the y. And of course, the x coordinate tells you how to move left and right, and the y coordinate tells you how to move up and down. Okay, so let's say, for example, that we had the point 6, 8. All right, so I'm going to, on the x-axis, I'm going to count over 6 spaces, which is here, and then I'm going to count up 8 spaces. That's 5, 6, 7, 8. It's like right there. Let's put a point. 6, 8. Okay, so I've just plotted a point. Let me just call it something. I'm going to call it P, for example. Now, this coordinate plane that's right here that we've been talking about, it is sometimes referred to as a rectangular coordinate system. Rectangular coordinates. And there's a couple of reasons for that. I mean, take a look at each of these little squares here. To grid this thing off, squares are rectangles, so that sort of makes sense. And the scale here doesn't have to always be the same. If this is, say, 1 inch, this does not have to also be 1 inch, which is where this whole rectangular idea comes from. Now, you can also visualize this like so. If you trace a segment straight down to the x-axis from your point P, which I forgot to label P, okay, and then one over here to the y-axis, you can see that this traces off a rectangle right there, okay? Now, this is not the only kind of coordinate system, but at this point in your education, it's the only kind that you've seen. In honors geometry, at some point, we'll look at least one more kind of coordinate system that mathematicians use to locate points. But for right now, that's what we're dealing with. Okay, so we've talked about plotting points. It's fairly easy to do. Now, next up, we want to talk about finding the distance between points. To find distance, there is a distance formula, which we will derive and prove in honors geometry this year. But up into this, like in your education here, it was just an application of the Pythagorean theorem, which has to do with right triangles. And you're looking at this and you don't see a right triangle, but you can make one. And the way that I'm going to make one is first with my eraser tool and get rid of this. And I'm going to trace this thing back to point O, the origin right here. If I just make myself a segment, right, with point P, you can see that that now traces off a right triangle. And in order to find the distance from O to P, that segment right there, it's just the length of the hypotenuse. Maybe I just call that thing C, and I would have to find my A length and my B length. Well, this is in the coordinate plane, so it's pretty easy to just count up left and right and up and down for you to see how long each of those sides are. But we knew how big they were anyway because this was the point 6, 8, which means that the A value is 6, the B value is 8, and then you could just use your Pythagorean formula in order to go 6 squared plus 8 squared is equal to C squared, and you're solving this thing for C. 36, 64, C squared, that's 90 plus 10 more is 100. C squared, you take the square root of both sides and you get 10. So your hypotenuse is 10, which means that O to C is also 10. Now this works whether this is connected to the origin or not. Let's say, for example, I am going to snatch this right here, and let's just move it to some other location like this. Now, obviously point P is no longer at 6, 8, so let me actually delete those coordinates. Let's see where it is at. I've got 1, 2, 3, and up 1, 2, 3, 4. It's at 3, 4. And then over here, point O is at 1, 2, 3, -3, down 1, 2, 3, 4, -3, -4. Okay, and it all still proceeds in the same way. Now you can see the bottom of my right triangle is kind of missing here, so you just add in an extra little segment there, and now you have your right triangle. If you count up these boxes left and right, 1, 2, 3, 4, 5, 6, you got 6, and then going up, 1, 2, 3, 4, 5, 6, 7, 8, you got 8. Use the Pythagorean theorem, you can get 10. So that should take care of plotting points and using the Pythagorean theorem to find the distance between the 2 points that you were given here. Next, before I forget, one of the things that a common mistake that students try to make is they want to count diagonally across the grid marks like this to go that this is 1 and 2 and 3 and 4 and so on, but you can't do that. And here's the reason why you can't do that. Let me just kind of zoom in on just one little square that's right there, one of these little units. And I think that you can agree that this length down here is 1 and going up is also 1, right? Basically traces off a square, which I'll draw like this. I'm supposed to snap in and make myself a perfect square. There it goes. Okay, so this is my 1 unit on the bottom, and this is 1 unit over here going up vertically. And then if I were to connect these 2 points going across the grid marks, again, this is the square that I just made, zoomed in version of this guy that's right there, 1 by 1. And then if we were to use the Pythagorean theorem in order to find the length of that hypotenuse, can this C also be 1? No, that's impossible because, see, the hypotenuse is always bigger than the 2 legs that make that right triangle. So if you were to go 1 squared plus 1 squared is equal to C squared, you get a 1 plus 1. You get a 2 is equal to C squared. And this is not a whole number. This is an irrational number. You take the square root and you get C is equal to the square root of 2, which is about 1.4. Definitely bigger than 1. Okay, all of that to show you that when you're in the coordinate plane and you're counting distances, counting boxes only works left, right, up, down. It does not work diagonal. To do diagonal, you're going to use the Pythagorean theorem. Okay, next up we're going to talk about some slope. Slope is a measurement that describes, it describes a number of things. One of them is a rate of change in a real world situation. Some quantity, maybe a distance, could be changing with time. In the coordinate plane, it measures basically how steep this thing is, okay? So if I were to go and erase a little bit of this, clean this thing up, get my eraser tool, there we go. Let's clean up some of this stuff. The rest of it is okay. I don't care about distance. What I care about is how tilted or how slanted this thing is. And the slope formula looks like this. Slope is equal to the rise over the run. Now the rise has to do with the y coordinates here, and the run has to do with the x coordinates here. In terms of a formula, that looks like this. y2 minus y1 over x2 minus x1. Now, which one is y1 and which one is y2 really doesn't matter, but once you have decided on the order of those 2 things, what you do is you keep it consistent for the bottom. When you find the distance or the difference between y2 and y1, what you're essentially doing is you're finding this vertical length that's right here. So watch. I have a 4 and I have a -4. If I were to subtract those things, 4 minus a negative 4, these two negatives, of course, cancel each other out, and I get 8. And that's the same thing as if I were to just count these things up, right? So I have a rise of 8. So for this, that's going to be up here on the top. Okay, and then for the run, again, I can do this by subtracting my coordinates. And it is essential that you keep it in the same order. Remember that I went from the P coordinate to the O coordinate. So whenever I do the X's, I want to do the exact same thing. So 3 minus a negative 3 minus a negative 3. Again, the negatives are going to cancel each other out. And then I get my 6. So I have a run of 6. And of course, you can notice that you could just count those things up as we did whenever we measured the distance between point O and P. So that's going to go on the bottom. And you can leave it like that, or I would recommend reducing. We have a common factor of 2, so that'd be 4/3. Okay, so again, you can do it if you have yourself a picture. Very easy to count up your rise and count up your run. Some people do the triangle, the right triangle off in this direction because they're counting up first and to the right. It really doesn't matter. You can also just straight up use the formula as we sort of did whenever we plug the numbers in here with the 4 minus a negative 4 and the 3 minus a negative 3. Okay, so that's going to take care of writing the slope between the points, and then finally writing an equation of the line. So if we pretend like this is our line, we want basically, what is the equation that relates all of the points x and the y coordinates? It is a linear function and it comes in multiple forms. So let's talk about some of those forms. So these are linear functions. In this case, linear refers to two things. It refers to the fact that the graph of this thing is going to be a line. It also refers to the x's and the y's both having the highest power being 1. So a function, if you remember, means that every input has exactly one output. All right, so there's a whole bunch of different forms. Mostly people remember this one, y equals mx plus b. This one is called slope-intercept. And the slope-intercept, it's called that, of course, because you got a slope here for your m, and then you have a intercept, specifically the y-intercept for b. Okay, another one, a little less common, but in my opinion, vastly superior, is called point slope form. It's y minus y1 is equal to your slope, m, times x minus x1. In this case, when it's called the point slope form, the point in question is x1, y1. That's not a variable. That's a point and coordinate in order pair that you're given. The x and the y without the subscripts, those are the ones that are the variables. And then, of course, your m is going to be your slope. Slope that you have either already calculated, like this, or slope that's given to you, or whatever. There is another form of the equation of the line that you probably learned in algebra, which is called standard form. Ax plus by is equal to c, standard form. And this arrow's bugging me, so I'm going to fix it. Okay, standard form, though, you don't get any slope, you don't get any y-intercept, you don't get any of that essential information that you get from these other two forms. Okay, now if we look back at the question, it says in point slope form, so we want to use this one, which is really easy to do. So if we're using this OP as our example, I already have the slope calculated. It's right here, it's 4/3. All I need to do is just choose one of my 2 points to put into the formula. Pay attention to the fact that the formula already has minuses in it. So if you use a set of coordinates that have negatives, then those negatives are going to cancel out and make a positive. So let's use this example. And to show that they're both exactly the same, whether I use point O or point P, I'm going to convert them in a second to the slope-intercept form. Okay, but we're going to start with point slope. I have the point P, which was 3, 4. I hope that's not actually the same point that I had. Okay, good, it wasn't. 3, 4. Yes. And then we calculated our slope as 4/3. All right, putting these things together, I have the equation y minus y1. My y1 is not that one, that's x1. x1, y1 is 4 is equal to my slope, 4/3 times x minus my x1, which is 3. And I'm done. You don't have to do anything to it. You do not necessarily have to convert it into, say, slope-intercept form. Unnecessary. The question even specified to put it in point slope form, so we're done. Now, it's not unique. A given line, like the line that we have here, OP, has a whole bunch of different lines depending on a point that you choose for it. I'm going to choose now point O and do the same exact thing. This one's -3, -4. So point O, that's a P. O, -3, -4, slope, still the same, 4/3. Okay, and now putting these things together, here, I have y minus, again, this is x1 and y1, a -4. And then notice that the two negatives are going to cancel each other out, so I could have just gone y plus 4 is equal to my slope, which is 4/3 times x minus, and then my x1 is a -3. So minus a -3, the negatives cancel, which means I could have just done +3. Now, if you look at these two equations, they're different. And I forgot my parentheses over here. They're different, but they still represent the exact same line. In order to see that, I'm going to convert them both into slope-intercept form, because any given line is only going to have one slope and one y-intercept. So it's a very handy way to see if two equations represent the same line. Now, just to be clear, you don't have to do this. I'm just trying to show you that both of these equations, while they're different, they represent the exact same line. And I'll have to distribute here through the parentheses. And I would have y minus 4 is equal to 4/3 x. And then if I take 4/3 and I multiply it times -3, that's like -3/1. My 3's are going to cancel each other out, and I just get 4 times basically -1 here, which is a -4. Okay, and now I just have to add this 4 to this side. If I add 4 to both of these sides, you can see it's going to cancel out, and I have y is equal to 4/3 x. Well, here, let's look back at our equation. The y-intercept, it disappeared, right? It's gone, which means the y-intercept is 0. The y-intercept in this picture looks like it's 0. That checks out. All right, last up, let's just verify that this one also does the exact same thing and gives us this slope-intercept form, okay? So I will have to distribute once again. So let's distribute right here. And I have y plus 4 is equal to 4/3 x plus, and then just like it did over here, 4/3 times 3, these 3's are going to cancel out. It's going to leave me with a positive 4 this time. I'll have to this time subtract 4 from both sides to isolate the y, and these 4's are going to cancel out, and everything works out as intended, or as expected. And we have the exact same equation. All right, so that should wrap it up. All of the different things that you learned to do back there in 8th grade math that cover plotting points, finding the distance between points, finding the slope between points, and then also writing an equation of a line through those 2 points.